Hello everyone. Today we are going to be studying a very important topic, tacheometry, which is a very deep integral part of our surveying. So we are going to be studying the topic tacheometry and its application, and we will also solve two examples to make this concept more clear. So what is tacheometry? Tacheometry is a system of rapid surveying. It is a system by which we can measure horizontal as well as vertical distances on the ground on Earth, and we do not need to use chain or tape for this. So it simply uses the concept of isosceles triangle and the ratios to measure the apex as well as the length across points A and B, etc. So for tacheometry, where it is used, tacheometry is a very important tool which is used in topographic maps and in measuring horizontal and vertical distances. Survey work is difficult in terrains which has uneven terrain or where there is cliffs and slopes and where a use of tape and chain is not that appropriate. So we are using this in highways, railways, and establishment of secondary control points. So what are the advantages of technology? We can have easily used theodolite and temporary level or chain or tape to measure the horizontal distances on the ground. But in uneven terrain where they have broken boundaries, safe slope, undulations, or somewhere like rivers and all, it becomes difficult to measure the distance because of these obstructions. So it is used in the preparation of contour maps in which horizontal and vertical distance is required to be measured. It is used in highway projects, hydrological projects, survey, and etc. So the advantage is we do not have to walk through and use tapes and chains or dumpy levels. It is just simply like theodolite, which has transit, okay, and has an analytical lens. It is used it is used where accuracy is not required. The only disadvantage, kind of a disadvantage, where the accuracy, but it's a very cheap instrument and economical instrument which saves you both time and money and gives you good results. So what is tachometry? How do we use it? So there are basically two methods of tachometric method. One is setting method and other is injection method. Setting method is generally classified into fixed area method and movable method. In fixed area method, the leveling staff is fixed and the or movement of this tachyometer, the instrument which is used to measure the distances, is fixed in horizontal plane and the stadia remain intercept remains fixed. Whereas movable, the stadia can do not remain fixed, and this instrument can be used in movement horizontal as well as sometimes vertical direction as well. And then the other topic is tangential method, and the tangential method can be also be classified into two types. Actually, it is one only, but it can be classified where one is the line of sight. Line of sight is at an inclined angle with the leveling staff, while the other uses the line of sight is perpendicular to the leveling staff. So further we move and we use the stadia tachometer tachometry thing. So it is generally the similarity method. I told you it is a concept of isosceles triangle. It uses the concept of isosceles triangle. So D1, D2, D3 are the distances of tachometer from apex O, A, B, and C from apex at the point of tachometer O, and S1, S2 are the S1, S3 are the stadias. This is the stadia 1, 2, and 3. So yeah, so stadia method we can use this, and this of two types, fixed end method and movable head method. So fixed end method is where the restrictions is there in horizontal direction, the stadia is no. Actually, and we can use the formula D is equals to Ks by plus C, where C is the correction vector, S is the stadia intercept, and K is the constant, which is generally focal length by I is equals to 100. I is the stadia intercept. So how is tangential tachometry we can deal with? Tangential tachometry is generally used in places where we have steep slope and we have different terrains. And this concept is used when stadia hairs are not present. This is very important. Stadia hairs are not present in the diaphragm. So we do not know where S1 and S2 is, so we cannot find out the stadia difference. So we target the angles and we can use the simple triangle method to identify these things. So what are the formulas? Formulas are these are case 1, case 2, and case 3, where the angle this is the axis of the instrument as well as the reduced level of the staff, and the angles are above the axis. Both angles are above the axis, so we use the formula tan theta 1 is equal to v by d, tan theta 2 is equal to v plus s by d. While in case 2, the angles are both are below the axis, and then also we can use the formula tan theta 1 v by d, tan theta 2 v minus d by s. Remember, minus sign comes when there are bigger angle, the angles are below the axis. Third is when one angle is above the axis and the other angle is below the axis. So we can use tan theta 2 is equal to s minus v by d. The bigger there, this is below and this is above. So and tan theta 1 becomes v by d. And there can be two more further classification where theta 1 is greater than theta 2 and theta 1 greater than theta 2 on when both the angles are below the axis and one angle is below the axis, one angle is above the axis. So here we use the formula v minus s by d and s minus v by d, tan theta 2 and tan theta 1. V by d remains constant, all that is tan theta 1 remains v by d in all the formulas. So further we will be using these to identify and to find out the distance v, the CADR intercept, and also the distance from point 0 O to A, that is tachymeter to A point. So this is an example. A tacheometer was set up at section A and the readings on the vertically held at shaft. So at point B, benchmark gave the readings as 2.175. This is 2.10 meter and 2.075 meter of the upper, middle, and lower interest areas respectively. Reduced level at A is 100 meter. Focal length by eye, that is area, the constant K is given as 100. Backside is 2 meters. Correction factor is 3 meters. That means this instrument has not used analytical lens. If we use analytical lens, the correction factor automatically comes to 0. So, how do we use the method to evaluate the distance? Also evaluate the reduced level at B. So it's very easy. What we do is we find out the stadia difference. What is the stadia difference? Which is 2.175 meter, that is upper stadia, minus 2.075, which is the lowest area, and it comes to be 0.15. The K is already given as 100, which is F by I. So we simply use the formula of the stadia method, which is K into S plus C, and C is the correction factor. So D comes out to be 15.3 meters. So if you want to find out the reduced level at B, what we do is we use the reduced level of A, which is already given in the form question. We add the backside to A, which is already given in the question, and subtract the central area from the reduced level A, which gives you 100 plus 2 minus 2.1 gives you 99.9 meters. The other is use of tangential method, which is it is used to evaluate the tangential method is used to evaluate the distances. So let's see the question. Use a tangential method to evaluate the distances of a tree from a decameter if two angles theta 1 and theta 2 are respectively given as these. The angles are from the top of the tachometer. Remember, it should be above the tachometer, and this is a simple question which deals with both the angles above the theta 1 and theta 2. Further, we will always also see the questions which deals with angles below the axis and one above and one below the axis. Reduce level of the tachometer is into meter, and value of S, the area is given as 2. So since V and D are both unknown, but theta 1 and theta 2 are given, we use the concept of tangential method of tacheometry, which is tan theta 1. We find out that 2, we form two equations, which is D is equal to 10 theta 1 given into D, which is V is equal to 0.1323 D. Then theta 2 becomes V plus S by D. V is equal to 0.1422 D plus 2, which is already given here as backside. And equalizing 1 and 2, we get the answer as 62.26 meters. So thank you.